Hello? Yeah. Now whether board is visible? Fast, come fast. Whether board is visible? Yeah. Good morning. But board is visible? Okay, done. Yes, Gaha. So, okay, done. So, since board is visible, now I was explaining, right? Because some of you had written, or one person had written option B. And if I am right, it was Achyuta, or who has written that answer? So, option B, you people have given. Okay? Now, we will see. Now, naturally, fluoride cannot be the answer. Right? Now when it comes to O minus, naturally it should be unstable. It is unstable. Since O minus is there, it should be unstable. Right? So it wants to get converted into O minus 2. That is one thing. But when it comes to oxygen, this is the size of the oxygen and this will be the size of the oxide, okay, and this will be the size of the O minus 2, sorry, it's not oxide, oxyanion, okay, na? That is with 1 minus charge. So this will be the size and this will be the size of O2 minus, that is oxide. Fine, so that is one thing. Now when I am having oxygen, this is oxygen, this is oxyanion, okay, so this is oxide. So that's where I have the condition. Now when I am talking about O, so naturally option C is getting converted into oxyanion. So this is option B. This is related to option B. So this is related to option C. Now sodium, no, it cannot be. All of us we know that sodium cannot be. Right? So in that way, if you see the structure, means atomic size, I have written the atomic size, right? Which one you feel better one? Whether option B or option C? Ashish has written, or some of you have written option C. So option B or option C, I have written the atomic size or atomic radius, or here in this case ionic radius. So we can clearly tell that since already size is little bigger, another electron, it will be bit difficult compared to here. Since size is small, it can take the electron, right? So therefore option C should be the answer. Oxygen will have the higher affinity compared to oxyanion. All of you have understood? So that's where we have the option C as the answer. So what is the reason? One reason is instability. O minus is unstable, no doubt. Along with that, when oxygen has taken up one electron, its size has got increased. Now nucleus is far from the outer shell. So at taking the another electron, it will be difficult compared to atom, oxygen. Fine. So all of you have understood. So for question number 16, which should be the answer? Option C should be the answer. Any doubt? Okay, fine. So we will move to the question number 17. Ionization enthalpy 1. I will write it as IE1 and ionization enthalpy 2. IE1 and IE2. What do you mean by IE1? Ionization enthalpy 1 and ionization enthalpy 2 of magnesium are 178 and 348. 178 and 348. kilocalories per mole. Kilocalories per mole respectively. It is respectively. Okay. The energy required for the reaction. The energy required. The energy required for the reaction. The energy required for the reaction. Reaction is here. Magnesium in gas state getting converted into Mg plus 2 in gaseous state plus 2 electron. Okay. So energy required for the reaction is option A 170 kilocalories. Option B 526 kilocalories. Option C minus 170 kilocalories. And option D minus 525 kilocalories. Can anyone of you tell me what should be the answer? Okay, once again. Okay, board is not visible. Okay. 1 minute. Once again, they are telling say. Yeah, all of them. Okay. Now whether board is visible? All of you can see the board now. Whether all of you can see the board? Okay. Answer fast. All of you can see the board. So if it is visible, shall I start? Hello students, are you there? Maya? Huh? I will switch off the light. But their messages I can't see. They will be responding, na?
A little bit you can open it this total.
Okay. But their messages, it's not coming. I think. They will be sending the messages. They are very active. But I cannot see messages. I'm going to try again. You just ask. I'll give try again. Madam, pen is fine, I think. But they used to send messages. Now no messages are coming. I'm asking them whether it's clear, but still I'm not seeing any message. Okay. No, it's not coming here. You will not have your breakfast. It's not coming here. Okay. Oh, they had already sent. It's absolutely clear they are telling. Okay. Okay, fine, Appa. So, shall we start? I was not able to see messages. Okay, we'll start. Okay, option B. Option B. Okay, very good. 526. Yes, option B should be the answer. Okay, now for this question, option B should be the answer. That is because, say for example, IE1, that is magnesium, is in gaseous state and it is becoming Mg plus. Right? So that is nothing but IE1, ionization enthalpy 1, where one electron has been removed. So what is the value? Delta H, that is ionization enthalpy is equal to, delta H is equal to how much they have given? They have given 178. Right? So next one, magnesium, that is magnesium ion, whatever is there, it will get converted into magnesium plus 2. So that is ionization enthalpy 2, right? So another electron. So what is ionization enthalpy value? That is 348 kilocalories per mole, right? Kilocalories per mole. So therefore, if I see the reaction all together, where magnesium ion and magnesium ion will get cancelled, so net reaction will be magnesium IE1 and IE2, we should be adding up together, magnesium plus 2 plus 2 electron. What will be delta H, that is ionization enthalpy is equal to, as you people have written, it should be 526 kilocalories per mole. Absolutely fine. Okay, so that's where we have the ionization enthalpy. Final ionization enthalpy will be 526 kilocalories per mole, because they are talking about this particular reaction. Fine. So all of you have understood. So that's where option B should be the answer. All of you are correct. Very good. So we'll move to the next question. So this one was from, I think, JE questions. This was from JE. Okay, so we'll move to the next one. Hydrogen, one minute, question number 18. So hydrogen by donating, hydrogen by donating one electron, naturally it will be having one electron only, forms H plus, forms H plus. In this property, it resembles with, so this was a JE question. So option A, transition metal, option A, transition metal, option B, alkaline earth metal, alkaline earth metal, option C, alkali metal, and option D, halogens. Option D, halogens. Right? So this is where we have the question. Right? So what is that question? Hydrogen by donating one electron forms H plus, that is proton. In this property it resembles with transition metal, alkaline earth metal, alkali metal and halogens. All of you are absolutely fine. Absolutely correct. Yes, it belongs to or it resembles the alkali metal because we know that we have sodium which can donate one electron and become Na plus. Right? So that's what hydrogen is doing. And that's what I told. Due to this one of the property, it has been placed along with the alkali metal. Due to this property of hydrogen, it has been placed along with the alkali metal. But due to its resemblance with halogens, where it can accept one electron and it can attain the inert gas configuration, that is helium. So therefore there was a confusion. So whether we should include this one in alkali metal or halogens. So therefore they have placed that one above the periodic table. But otherwise it will be placed along with the alkali metal. Fine. So we'll move to the next question. Question number 19. Okay. The 10th elements. The 10th elements in the periodic table. Periodic table, I will use the short form. In the periodic table resembles with the, it was related to some competitive exam. Okay. So A, first period. A, first period. B, second period. Second period. Oh, I would have written now regular second. So then fourth period. Then D, ninth period. Then D, ninth period. Tell me. To which period? Okay, Ashish has written option B. Ashish has written option B. Okay, all of you are writing option B as the answer, right? Now when I am telling 10th elements in the periodic table, that means I am talking about element having atomic number 10. Right? I am talking about element having atomic number 10. So that means if I write the electronic configuration, so it will be 1s2, 2s2, 2p6. So right? So that's where it has been done. So 10 electron it is done. So I am talking about the element neon. I am talking about the element neon. So therefore it belongs to second period. Why? Because there is 2. Outermost energy level is 2. So therefore it will be second period element. Okay. So specifying that element will be neon. So therefore option B should be the answer. Okay. So we'll move to the next one. Question number 20. The elements with question number 20. It was a JE question. The elements with n is equal to 2, L is equal to 1, M is equal to 1 and S is equal to minus half has the following position. Has the following position. Has the following position in the periodic table. Has the following position in the periodic table. So periodic table I am using the short form. So option A, group 7A and period 2. And period 2. Option B, group 0 and period 2. And period 2. Option C, group 7A and period 3. And period 3. Option D, group 0 and period 3. Can any one of you answer for this? The elements with this one, to answer you should know atomic structure. That's very important. Quantum numbers. So n is equal to 2 means principal quantum number is 2. So L is equal to 1. That means subshell notation. So M is equal to 1. Right? Magnetic quantum number. Then S is equal to minus half. So Achyuta is spelling option A. Group 7A and period 2. Group 7A and period 2. All of you will agree? Group 7A and period 2. Achyuta is spelling. All of you will agree with that? Please remember, this is old nomenclature. Okay, other answers are coming. So it should be option B. So I am getting two answers, option A and option B. Now we will make it very clear. When I am talking about 7A, Achyuta, so and even for others also, when I am talking about option A, I am dealing with the D block elements. I am dealing with the D block elements because 7A means in the modern periodic table means at present we are going to mention that one as 7 with integers, right? So here it is Roman number 7A, older method. So that's where 7A means group 7. Group 7 belongs to transition metals, that is D block. So that means L value should have been different because when L is equal to 0, we are talking about S subshell. When L is equal to 1, we are talking about P. When L is equal to 2, we are talking about D. When L is equal to 3, we are talking about F. So what is that L value they have given? L value they have given as 1. So due to that they are talking about P sub shell. So naturally, which second period only it should belongs to? Which second period only? So naturally it will be group 0 and period 2. Group 0 and period 2. Why it should belongs to second period only? Why not period 3? That is because when n value is equal to 2 they have given. Naturally this one and this one is cancelled. They are not at all the options. Because period 3 they have mentioned. But here n is equal to 2 is there. So C and D is not there in the list at all. So therefore option A or option B should have been. So naturally since L value is equal to 1, they are talking about P sub shell. So we will make it as option B, that is group 0. So group 0 means inert gas. So group 0, 0th group, right? That is nothing but inert gas. So period number 2, inert gas is nothing but neon. So that's where they are talking about the neon. Okay? So that's where you should be knowing the information about the atomic structure, that is quantum numbers. That is very important for your board exam also and for competitive exam also. You can expect the question on quantum numbers. Okay? So we'll move to the next one. Question number 21. The correct order of increasing radii of ions, the correct order of increasing radii of ions, Br minus, fluoride, oxide and sulfide is as follows. Fine. So that is option A. Br minus, that is bromide, less than fluoride, less than oxide and less than sulfide. Option B, sulfide, less than oxide, less than fluoride and less than bromide. Then option C, fluoride, less than oxide, less than sulfide, less than bromide. And option D, fluoride, less than bromide, less than oxide and less than sulfide. Can anyone tell? So the correct order of increasing radii of ions, bromide, fluoride, oxide and sulfide is as follows. So that's where we have the options. Option A, Mansi. Darshan has also written as option A. Right? Okay, fine. So we are finding option A as the answer. We will see. Now, when I am talking about these species, we have two negatively charged ions. Right? Two negatively charged ions. Means two minus charge is there. That is oxide and sulfide. So among these two, since oxygen is here and sulfur is here in the group 16, so this is oxygen and this is sulfur. So already they have the difference in their atomic size. Now I am talking about O minus 2 and S minus 2. Fine? So naturally, this is where we have the arrangement. But if you see the halogens, so I have fluorine, this is fluorine, then this is chlorine, and this is where we have the bromine. It belongs to period 3. Bromine belongs to period 3. So fluoride, chloride, then bromide. So this is where we have the ions. Sulfur belongs to period 2, but period 3, but bromine belongs to period 4. So that's where we have the difference. Sulfur belongs to period 3, bromine belongs to period 4. Fine? So that's where we have the difference. Now can you tell? And if you observe, there is something in this. If you observe it carefully, I can tell that fluoride and oxides are isoelectronic species. Oxides are isoelectronic species. Both of them are having 10 electrons. So both of them, they are having 10 electrons. Right? So fluoride should be of lesser size compared to oxide. What is the reason? The reason is nuclear charge is higher. In fluoride, nuclear charge is more. Or I can tell it is much rightward compared to oxygen. So therefore, we have the fluoride which will be having smaller size compared to oxide. And sulfur belongs to period number 3, bromide belongs to period number 4. So therefore option should be, yes, option should be C, not A. Option should be C. In option A, they have written bromide in the first. That's why it is gone. Bromide cannot be smaller, right? So that's where it is gone. When it comes to here, that's where it is a bit confusing. Option B, because they have given bromide in the last. They have given bromide in the last. Shri Vidya, what is that number you are writing? Total electron number. Okay, fine. So that's where we have the sulfide, oxide, bromide and fluoride and bromide. So that's where it will be a bit confusing. Right? But when they have written sulfide before the oxide, then it is gone. Because already sulfur is of larger size compared to oxygen. Naturally, sulfide should be much higher compared to oxide. Because both are having equal number of electrons. While going down the group, radii increases. Yes. Towards left of the group. Yes. Fine. So due to that, this is also wrong. And when it comes to here, it has to be wrong because bromide they have given here. It should have been last because bromine belongs to group 4. Period 4. So naturally option C should be the answer. All of you have understood? Fine. So we will move to the next one. Okay. So that is question number 22. Question number 22. Okay, 1 minute. Question number 22. But any doubts? Whatever we have discussed, any doubt in that? Fine. So, question number 22. Which one of the following? Which one of the following arrangement? Which one of the following arrangement represents the which one of the following arrangements represent the correct order of least negative to most negative, least negative to most negative electron gain enthalpy. Electron gain enthalpy, least negative to most negative electron gain enthalpy for carbon, calcium, aluminium, fluorine and oxygen. It was a NEET question. It was asked in a NEET exam. Okay na? And option is aluminium less than calcium less than oxygen less than carbon less than fluorine. Option B, aluminium less than oxygen less than carbon less than calcium less than fluorine. Then option C, carbon less than fluorine less than aluminium less than calcium. Okay, only for oxygen I have not written now. So carbon less than fluorine less than oxygen less than aluminium less than calcium. So option D, calcium less than aluminium less than carbon less than oxygen less than fluorine. Can anyone tell which one of the following arrangement represents the correct order of least negative to most negative electron gain enthalpy? Means from less to higher. Okay na? So least negative to most negative electron gain enthalpy for carbon, calcium, aluminium, fluorine and oxygen. So that means electron gain enthalpy, more energy should be released. That's how it has to be arranged. So Darshan is writing option D. Darshan is writing option D. All of you will agree with that? Option D. Many of you have written option D as the answer. All of you will agree with that? Electron gain enthalpy. Most negative electron gain enthalpy. Naturally, option D should be the answer because calcium, alkaline earth metal, very poor acceptor of electron, very less energy will be released. Wherever calcium will be first, that should have been the answer. Right? So here, calcium is not there in the first position. Here also, calcium is not there. Here also, calcium is not there. So straight away you can go for option D, no need to think. Right? Whenever alkali or alkaline earth metal is there, they should occupy the first position. Okay? More energy will be, less energy will be released because they are poor acceptors of electron. So among these four options, option D is the one where only calcium is the one which is in the first position. In the rest of the options, it's not there. Okay? So therefore, yes Sachita, therefore, since calcium is alkaline earth metal, it has to be in the first place where least energy will be released. Okay? So no need to go for second thought. Straight away you can take, no need to waste the time also. So calcium, since first position in option D should be the answer. Fine? If alkali metal is there as one of the element, then that should occupy the first position. That alkali metal should occupy the first position. Okay? So we will move to the next one. Question number 23. The first ionization potential. First ionization potential of sodium, magnesium and silicon are respectively 496, 737, 786 kilojoules per mole. the ionization potential of the ionization potential of the ionization potential of aluminium closest to, this was asked in AIIMS, that is related to All India Medical entrance. Earlier it used to be there. The ionization potential of aluminium closest to, option A 760 kilojoules per mole, option B 575 kilojoules per mole, option C 801 kilojoules per mole, and option D 419 kilojoules per mole. Okay. Can anyone? The first ionization potential of sodium, magnesium and silicon are respectively 496, 737, 786 kilojoules per mole. The ionization potential of aluminium closest to. Some of you have written option A. Some of you have written option A. Right? Now we will see. Now when it comes to sodium, it is having electronic configuration as neon 3s1. Right? So when it is getting converted into Na plus, that is nothing but neon 3s0. From S subshell, electrons are getting removed. So what is that value? That value is 496 kilojoules per mole. Another element, which is that one, magnesium. Right? Another next element is magnesium, neon 3s2. So it is becoming magnesium plus. Electronic configuration will become 3s1. So that means once again from S subshell only. So here it will be 737 kilojoules per mole. And now silicon. Now next one is silicon. So now silicon will be having electronic configuration of, can anyone? Silicon belongs to which particular period? Silicon belongs to which particular period? Anyone? Silicon belongs to which particular period? It belongs to period 3. It is next to the carbon. In carbon group 14, it is next to the carbon. Carbon belongs to period 2. It should belongs to period 3. Yes, very good. So therefore, we can take the help of which inert gas? So which can take which inert gas? Help of which inert gas? Yes, neon, right? So if you want to write a neon, then it will be, what should be the electronic configuration? So it will be 3s2, 3p2. Right? Now, silicon plus. First ionization potential they are talking about. Therefore, Si plus neon 3s2, 3p1. So here in this case from P subshell electrons are getting removed. Yes, Achyuta. From here P subshell electrons are getting removed. Right? So in that case, from P subshell electrons will be removed. In that case, all of them, they are in period number 3 only. So from P subshell, aluminium, they are talking about aluminium, right? So aluminium belongs to, once again, period 3. Aluminium, after the boron, group 30, aluminium is there. So neon, 3s2, 3p1. 3s2, 3p1. So it will become aluminium plus neon, 3s2, 3p0. Right? This is what it will happen. They have given the values here as 786. So here they are asking. Right? So some of you have written option B, right? All of you will agree with this particular option. All of you will agree with that particular option. Now it is very clear that when the electrons are getting removed from S subshell, so we have 496, 737. When it is removed from P subshell, now it has become 786. That is because decreasing in the atomic size. They are all alkali metal and alkaline earth metal. But here they belongs to non-metals. Aluminium is like a metalloid, but silicon it is a metalloid once again, which belongs to P block, where from P subshell electrons will be removed. So in that way, the value should be more than the sodium. Value should be more than the sodium. That is because one is, it is an alkali metal, where removing of electron will be easy. And aluminium, since it is on the right word to the sodium, so naturally a bit more energy is required here. So that should be more than 496, no doubt. But at the same time, it should be less than silicon. It should be less than silicon, because silicon is much more on the right side. Right side compared to aluminium. So therefore, it should be somewhere between 496 and 786. It should be somewhere between 496 and 786. Right? And even compared to magnesium, it should be bit less even compared to the magnesium. So therefore, it should be 575 kilojoules per mole. 575 kilojoules per mole. All of you will agree? Why should be slightly less than magnesium? Because here P subshell is involved, here S subshell is involved. So therefore, option will be B. Answer should be option B. It cannot be 801, omitted. It cannot be 419, omitted, because 496 is the minimum value here. 419 cannot be. Then 760. 760 cannot be possible. So due to that, it should be 575 kilojoules per mole. All of you have understood? So that's where even we have to consider the which subshell and what is the position of those elements in the periodic table. You should understand that one, then you should give the answer. Okay, in this case option B should be the answer. All of you have understood? Any doubts? So shall we move to the next one? Okay? Okay, fine. We'll move to the next one. Which is most basic oxide? It was a JEE question. Question number 24. Which is the most basic oxide? Which is the most basic oxide? JEE questions it is. 1. Stannic oxide, SnO2, potassium oxide, K2O, cupric oxide, CuO, and D, ferrous oxide, FeO. Right? So what is this? For your information, it is stannic oxide. Right? It is stannic oxide, where this one, tin will be having +4 oxidation state. So this is potassium oxide. Potassium +1, right? Oxide always -2. So here copper, since it is having +2 charge, so it should be cupric oxide. It's not cuprous. Cuprous will be Cu2O, just like potassium oxide. So since here ion will be +2, therefore it should be ferrous oxide. Okay, so that's where we have the oxides. Now tell me, which should be the most basic? Already we have discussed. Which should be the most basic oxide? Okay, Darshan has written option B, absolutely correct. Because we have a alkali metal oxide. So alkali metal oxide should be basic. Because if I take K2O, just like sodium oxide, which we have discussed, with water it will form KOH. It will form the potassium hydroxide. Same way, if I take K2O, if I treat with the HCl, it will become H2O plus KCl. H2O plus KCl. So that's where we have the basic character of potassium oxide. It can neutralize the HCl, even it can form the potassium hydroxide. Okay? Now, additional one, it's not related to this question. Additional thing here is, when it comes to stannic oxide, please remember, it is also an example for amphoteric oxide. You have to remember, it is an example for amphoteric oxide, same as that of the aluminium oxide. Okay? Cupric oxide, it is slightly amphoteric in nature. It is also slightly amphoteric in nature. Okay? But when it comes to ferrous oxide, it is also a basic oxide, but not as that of the potassium oxide. Potassium oxide is much more basic. Therefore, most basic they have asked. So ferrous oxide is also slightly basic only, because it can donate the electron to become ferric oxide. Ferrous oxide is slightly less stable. It will get converted into ferric oxide, that is Fe2O3, where iron will be having +3 charge, which is stable. Ferric ion is stable compared to ferrous. So therefore it will get converted into ferric form, ferric oxide. Okay, so due to that it is having basic character, because it can donate the electron. That's what the feature of base, right? They are the donors of electron. All of you have understood? Fine. So which is more amphoteric in nature? Stannic oxide. Next comes the copper oxide, that is cupric oxide. Okay, which is slightly amphoteric in nature. Okay, now last one. That is the correct order of, it is also JE question, the correct order of electron affinity. Electron affinity of the halogen. Halogen atoms are. Halogen atoms are. Option A, fluorine less than chlorine less than bromine less than, okay, it's not continuous. Okay, so fluorine less than chlorine less than bromine greater than iodine. Okay, option B, fluorine less than chlorine, which will be same as that of the bromine, which is greater than that of the iodine. Option C, fluorine greater than chlorine greater than bromine greater than iodine. And option D, fluorine less than chlorine greater than bromine greater than iodine. Can anyone tell? See, observe the symbols. It's a JE question. The correct order of electron affinity of the halogen atoms are fluorine less than chlorine less than bromine greater than iodine. So fluorine less than chlorine, same as that of the bromine, greater than iodine. Then fluorine greater than chlorine greater than bromine greater than iodine. Then option D is fluorine less than chlorine greater than bromine, greater than iodine. So which can be the answer? So which can be the answer? Option C. Okay. Still people are doing the same mistake. Achyuta. See here, option C cannot be the answer because they are talking about electron affinity. And fluorine cannot have more affinity for electron compared to chlorine. It's not electronegativity. They are talking about electron affinity. Shrishti. Okay? So that's where we have the electron affinity in the sense taking the electron. Electron affinity means taking the electron. Okay? Electron gaining. Okay, electron gaining. So which can be the one? Bit confusing, I can understand, because affinity means attraction also meaning. So if I consider electron gaining, option D should be the answer, because although fluorine is having higher electronegativity, it has less potential gaining of the electron compared to chlorine. So chlorine is the one which will be dominating. So that's what we can see here. That's what we can see here. Option B cannot be the one. Chlorine, bromine cannot be equal. So here, so they have written bromine greater than that of the chlorine, right? So therefore it is also wrong. Either it should be C and D, right? So normally electron affinity means we will consider electron gaining. If going with electron affinity, yes, this is the regular arrangement. That is electronegativity. Yes, this is the one. But electron gaining, then it will be dominating. Okay? So fine. So any doubts? Whatever we have discussed. So try to solve more questions, competitive exam questions. As I told, you can have the competitive exam books from learners also or any books. I have included some of the questions from learners, this one, whatever book is available. Okay? Okay, Shri Vidya. Okay, not clear. Fine. So I will explain it once again. Shri Vidya. Now when I am talking about electron affinity, the question was, they are talking about electron affinity. So normally people will get confused that they are talking about electronegativity. That is quite common. Because electronegativity definition itself tells that it is the ability of an element to attract the electron, shared electron. So attraction, affinity, they think it is same. But normally, when it comes to electron affinity, we are talking about electron gaining. We are talking about electron gaining. So therefore, as I told, if you take it as electronegativity, which is not absolutely correct, so if you take it as electronegativity, naturally fluorine is going to dominate, then comes the chlorine, then comes the bromine, then comes the iodine, which was there in option C. And people will go with option C, which is not actually correct, because they have asked about electron affinity. So when it comes to electron gaining, the meaning of electron affinity as electron gaining, then fluorine should be of less compared to chlorine, which will be of greater compared to bromine and iodine. So that's where option D was there. So we have to go with option D. So don't get confused. Normal electron affinity means taking the electron. All of you have understood? Shri Vidya, now it's clear? So that's where we have the options. Okay? Okay, in that case I will stop here. By this periodic classification is completely done. Okay? Take care. Bye.